Hey there, welcome back. Today we're going to be continuing our project on making Tic Tac Toe. And I think this one's going to be a little interesting. I think we're going to be jumping around a lot to a few different places because we're going to be setting up our grid as well as setting the base for some of the cell pieces for the buttons and all that good stuff. That may not make a whole lot of sense right now, but hopefully it will by the end of the video. So I think the first thing we're going to do is we're going to make a prefab for our buttons. So when the player clicks on one of the spaces on our board, it'll be able to show an X or an O. And what a prefab is just an example of a object that you want to reuse over and over and over again. I'll sort of explain a little bit more as I make it. So the first thing that we're going to do is we're going to go over to our hierarchy. We're going to go to our canvas. And within our canvas here, I'm going to right click and I'm going to go to UI. I'm going to create a button. And this is exactly like it sounds. It's just a button, which has this button component so we can register input from the player. And childed to this is a text object. But we're going to be using this button multiple times for each of the little cell pieces on our board. So the first thing I'm going to do is I'm going to go over here to the left to the button that we just created. I'm going to click it. I'm going to hit F2 and I'm going to write PR_cell. And for a lot of my objects, I like to use a prefix. And for prefab, I use PR. And maybe for textures, I do T_, and just a few of those things. As we sort of come across them, I'll probably point them out and talk a little bit more about them. But to make a prefab, it's really simple. We have this object within our hierarchy over here, and all we have to do is click and drag it all the way over to our prefabs folder and let go. And there we go. And we have this nice little blue cube that's going to be our prefab. And one thing that we're going to do to this prefab, just to sort of show the sort of editing that you can do with it, is we're going to come back over to the prefab that we have in our hierarchy. And if you notice, it's gone from white to blue. But if we go to our text, when we delete our text, we can go up here and we can hit apply. And then it'll also apply it to this guy right here. And if you notice, the text there is also empty. So one thing that we're going to be doing to this cell right here is we're going to go up here to our rect transform. This will automatically be done when we put it to the grid, but we'll just do it for now. We're going to go ahead and hold Alt and Shift, and we're going to click right down there to the left. And for simplicity's sake, we'll also make the width here 200, and we'll make the height of it 200. And what this gives us is a good visual indicator of the size of this button on our grid. So what we're going to be doing with this prefab that we've just created is we're going to be creating 9 of them within our script. So we're going to go ahead and apply our changes to this prefab. We're going to hit apply. And then we're going to go ahead and we're going to delete it because we're going to be creating them through programming. So we're not going to need this one already existing in the scene. So we're going to do that and we're going to delete it. And great thing about prefabs is that if you want another one, we can just drag this guy right back out into our scene, and there he is. So let's just undo that. So let's go ahead and let's make our first script. So we're going to go to our scripts folder. There's a couple ways you can make a script. It's quite a few actually. I believe if you go up here to assets, create C# script. If you want to and you already have an object selected, if you just start typing something in, I believe it'll say new script, and it'll bring up if you want in C# or Java. I don't really use that because I think if we create and we add it, it just adds it to the root of our assets folder, which I'm not a fan of. So let's just go ahead and delete that. But if we go and right click to our actual scripts folder, we can hit create C#, and then we can name it. So we're going to be naming this grid, not griff, grid. And then if we double click this, it's going to open it up in our whichever editor that you're going to be using. It may be Model Develop or maybe Visual Studio. In my example, I'm using Visual Studio 2015. It's not really, doesn't really matter what version you use as long as your autocomplete is working and all that good stuff. But I think this font that we have right now is big enough. So here we are in our grid script that we've just created. And if you notice, there's a few things that we already have here. We have some statements here up at the top. We have this public class, and we have a few start and update functions. So just to begin and maybe give you a quick overview of what everything in the script is, just so you can have a rough idea. I'm not going to spend my entire life explaining it to you, but it should be just clear in your head of like, oh, what it is and if you have to worry about it or not. So up here we have namespaces, and namespaces are just essentially a way of organizing large code bases. And the Unity engine, as you can imagine, is a pretty large code base. So sometimes to access particular functions of the Unity engine, we'll have to use a namespace. And then here we have our class, and if you remember, we named our script grid. And sometimes when you do that, or when you do it, it'll automatically name your class the same. And so in this class, it's grid, and it inherits from a class called monoBehavior. Now, you really don't have to know anything about that right now, but if you want to have a script that is attachable to objects within the scene, it needs to inherit from monoBehavior. And then we have these two functions here. We have one that's called start and one that's called update. And for start basically means that, if we look at the comment here that's automatically put in here, it's used for initialization. And it's basically, hey, as soon as our project starts, we're going to run the start function. And then right down here, we have our update, where this runs every single frame of our program, meaning if our program is running at 60 frames per second, this piece of code or all the code within this function is going to run that many times per second. But not every script needs to use these. And as an example, our script is not going to need to use these in the end. But I think we're going to be using start as of right now as a building block, so I can just show you this grid in action, because I would like to see something on the screen from our programming. And within this episode, it would be really lame if we did a bunch of programming and then it led to nothing. So let's go ahead and delete this statement right here. And then we're going to get rid of this comment. And one thing I like to do, which is cool within Visual Studio if you're using Visual Studio, is that it has a very bare bones auto formatting feature, which if you hold Control, let's see, I'm gonna write a comment here, and it's K and it's D. You may have to look this up and play around with it because Visual Studio has combo shortcuts where you can hold a modifier button and then hit two keys at once. So I believe it's if I hit hold Control and hit K and D, if you notice all these brackets have shifted around. And this is very useful if you get a script from someone that's kind of like, it's kind of ugly and you don't want to spend a whole lot of time working with things, because a lot of people, well, maybe not a lot, but MonoDevelop as an example likes to put the brackets like this. I like to have them stacked like this. So when you have things that are nested, it's very easy to see what's what. I also like having that extra bit of space there, but that's just me. So the first thing that we're going to do within the script is we're going to create a variable. But first, we're not going to push our bracket down. So we're going to write public game object, and we're going to write m cell prefab. All right, cool. So this is a variable, and it's going to be holding a reference to that prefab we just created and we put into our assets, because we're going to be wanting a reference to it so we can create a lot more of it. We can't create anything if we don't have anything, or we can't copy anything if we don't have anything to copy, right? So here we use the word public so other things can have access to our grid. And we need to have that public access so we can drop the object that we just created, which kind of hints at our next word here, which is a game object, which if we read the definition, it's a base class for all entities within a Unity scene. And like I said before, like our scene is basically going to be holding all of our assets as well as our scripts. So another way of saying that is entities. And then what we want to call it. And I've named mine M cell prefab. And M, I think I usually use the word member for it, or if it belongs at the top here, it belongs to this script and it isn't local to any function. That may not make a whole lot of sense if you don't have a lot of programming experience, but don't worry, as we go through this script, you'll learn a little bit more about that. But for the naming of this object, you can completely leave the M out. You may even want to, some people like to put an underscore, so like that. Some people like to do both, and they like to put an M underscore. But for me, just like M, gets the job done. Depending upon if you're working with people, this may be something that is decided beforehand or something like that. But for me, since I work by myself, this is what I do. So now that we got that excessively long explanation of what a variable is, let's make another one. So now we're going to make one that's private. Well, actually, before we do that, let's save this. Let's go back into Unity and let's create another script. So let's go ahead and right click on our scripts folder. We're going to create cell script and we're going to name this cell. And we're not going to write anything in this video. Well, we're not going to write anything in the script in this video, so don't worry about that. But we'll just need it for the grid. So we're going to create that and we're going to go open our grid again and we're going to reload. Yes, cool. And we'll save it. Okay, so now we're back in our grid where we're going to be creating a private variable like we were before. So we're going to write out the word private, which as you can imagine is the opposite of public. I'm sure you already got that. And this is something that's only going to be accessible to this script, so the grid. And this is a great way of keeping values or references to things that you don't want being edited by other functionality within your project. So it's a good thing to do that, because if you're working with other people, they may be writing something that is editing something within a script you wrote. It may create bugs or issues. So you want to try and reduce the amount of communication between things, because it will certainly prevent problems down the road. So we're going to be creating an array of cells. And we just made that cell script so we could use the word cell. And we just made that class, just like that. And we're going to make this an array. So we're going to put brackets right behind this. And what an array is, it's a collection. And since we're going to be creating 9 of these cells for our Tic Tac Toe board, we're going to want one place to store each of those cells. So we can have a reference to all of them. And when we need to reset them or anything like that, we can easily go through all of them and clear them all out. So going back to the variable that we just created, GameObject, that's the type of the variable. So for this, the type is going to be cell. But in this case, it's going to be a cell array. So now let's name our variable. So we're going to do a space, we're going to do m cells. And then we're going to do an equal sign, and we're going to do new cell brackets 9. So what this is going to do, it's going to declare an array that can store 9 items. And then we're going to create a function, much like this start function, but we're going to put the word public in front of it. And we're going to write void build, just like that. So right now, all you really need to worry about is that a function is a repeatable piece of code. And a lot of programming is basically writing functions and how to organize them and how to be able to reuse them most efficiently so you're not writing the same piece of code multiple times. But it's also good to name your function something that makes sense. As you can tell, our class name is grid, and we're going to name, since we named our function build, people know when you have a grid and you build, it's going to be building a grid. So within this function, we're going to create a for loop. We're going to write for int I equals 0, semicolon, I is less than or equal to 8, not 9, semicolon, I plus plus. All right, so what in God's name does all of this mean? Well, that's a great question. So a for loop is basically, based on this statement, do this thing that many times. So for int I is just short for index, equals 0. So we're going to start our index at 0. And we're going to run this while I is less than or equal to 8. So it's going to end up running 9 times. So it's going to run once for 0 and then 1 through 8. So 9 by the end of it. But that may change depending upon how many times we are, well, not how many times, but how we are adding to this index. And in this case, every time we run this piece of code within these brackets, we're going to add to our index by 1. But if we added it by 2 as an example, one way of doing that would be doing a plus equals 2. We would only do it, I think, 4 times. because we're cutting down by how many times we can go through this loop, while our index is going to be less than 8. Hopefully that makes sense. I think we're going to have another for loop within the project, or for each loop, so we'll have a little bit more experience there. So on the first line here, we're going to be creating a new game object. And a game object, like I said, is something within our scene. So we're going to be creating a copy of this prefab that we created. So the first thing we're going to do within this for loop is we're going to write game object, new cell, equal, instantiate. And instantiate is a very fancy word for just create. And we're going to be giving it an object. And if you can see in this little description here, it's looking for an object that says original. It's going to clone the object, essentially. So we're going to write m cell prefab, comma. And an interesting thing about this instantiate is that there's so many different ways of calling it. And if you hit your arrow keys, you can sort of siphon through, or siphon, I don't know if that's the right word. You can go through all of these different ways of calling this, where you can set the position or the rotation and all that good stuff. But we're not going to need that. We're going to be using, I believe, this second one here, where we're going to be passing in a transform. And a transform is basically what's the position or the rotation and the rotation of an object within the scene. But this particular transform that we're going to give it, it's going to be the parent. And if you remember, within our scene, we childed our lines to our canvas. So when we are building these cells, we want to child it to the grid. And we'll see a little bit more of that in the hierarchy. So we're going to write the word transform. And when you write just the word transform, it's going to reference the transform that this script is attached to. And you'll have more of a visual aid, like I said, once this script is done and we get back into the scene. And then on our next line, we're going to write m cells, brackets, going to give it our index, and equals our new cell dot get component cell. All right, so what this does, this line, is we're getting that array that we created up here at the top, and we're using our brackets, and we're using our index, because if you remember, we set it to 9, and as we're sort of going through this collection, we need a way of getting a specific object within our collection. So if we start this at 0, we can get the first thing within our collection. We can get it or we can set it. In this case, we're setting it because we're using the equal sign. And we're getting that new cell, that game object that we just created, and we're getting using the function getComponent, and we're passing in the type, which is going to be cell. So to summarize all of this in a bit more potentially meaningful way is we're creating all these objects, but then we're going to be getting a specific thing from each of those objects so we can store it for later use. And in this case, we're going to be storing the cell script that's going to be attached to each of our cells. So we can go through this collection of objects and we can call a reset function or something like that once the game is over. All right, and I think that's everything for now. So let's go ahead and save this by hitting Control S. We're going to minimize it and go back into Unity. All right, so now that we're back in Unity, I had forgotten to put the cell script, well, I forgot to create it previously, but also to attach it to our cell prefab that we created. So if we go into our prefabs folder, we hit the cell, and then we want to attach this cell script to it. So we're just going to click and drag. And there we go. So now he's attached to it. And if you remember when we were in Visual Studio, when we create this cell, we're going to be storing a collection of a bunch of references to these scripts. All right, so let's add our grid to our scene now. So we're going to go over to our canvas. We're going to right click. We're going to create an empty object, and we're going to call it PR underscore grid. And one thing that we're going to be adding to this is a grid component, which is something that is standard to Unity. So if we go to our grid layout group, there we go. And then we're going to also add a reference to our actual grid, or our grid script that we created. All right, so now let's set some of the settings for our grid. So the first thing that we're going to do is we're going to go up to the width and the height, and we're going to make it 600 by 600. Not 600 by 100, silly. 600 by 600. There we go. And then for each of these cells, now seeing that it's 600 by 600 and it's 3 by 3, we're going to divide by 3, so all of our cell sizes are going to be 200. much like the cell that we created earlier. These values will be overwritten, but it's just sort of a good indication of what the size is going to end up being. So we go back here. We're going to write 200. We're going to write 200 again. And then we're going to edit some of these settings where we're going to start, instead of the upper left, the lower left. So it's more sort of a grid where it's going to begin down here. Our origin is going to begin down here. And we're going to be building horizontal. That's cool. And then our child alignment is also just going to be in the lower left, just for simplicity's sake. And then for our constraint, I think we're just going to do a fixed column count. We can also do a fixed row count, but column's good too, where we're going to need 3. All right, cool. So all we need to do now is give it a reference to that cell we created at the very beginning. And we just click and we drag. And if you remember, we made this public, so this enables us to do this. And now let's create a prefab for our grid. So let's click our grid, go back over, and just drop it in right there. All right, I think we're good. So let's go ahead and hit Control S, and then we're going to hit our play button, and we're going to see if this works. All right. Nothing happened. Oh, you know what happened? See, this is when I say like I make a lot of mistakes. So one thing I forgot to do is why I left this start statement here is that we need to actually call our build function. It's not just going to run automatically. So when our project starts, we want to call build. There we go. Amazing. That's how programming works. So let's go back into Unity and let's hit play again. Hopefully this works. Ta-da! So there we go. So now we've created a whole grid of all these cool little buttons. Just like that. And what we're going to be able to do in the next video is click on these and be able to place an X or an O in them. I know we didn't get to it this video, but I think we made enough progress here for today where we actually managed to put something on the screen that we can kind of interact with. So hopefully you got to follow along and hopefully this was helpful to you. If you liked the video, feel free to leave a like. If you'd like to continue to follow along and make this amazing version of Tic Tac Toe, you can go ahead and subscribe. And if you needed any help or just wanted to say hello, you can leave a comment. So hopefully I'll see you next time.